Cocos, right? Cocos.
Yeah.
You got this TikTok channel. It's actually Cocos.
Which one?
TikTok channel. This channel, this one channel. It's called Destination Go.
Destination.
Yeah. Skydiving.
I'll pass like that.
As in one try. Especially like how far I saw it. I saw it like 400.
Really? 400. Oh, I heard that. I think got like a hot air balloon. That one maybe I plan to try that one. Yeah. I go see the review. It's not really good cheese. I think I read wrongly. I remember last time I read. Maybe
Alright,
the other
so
store.
right now let us continue the exercises here. So just now I just to show you, right? This is what we are going to find out the pad size. Alright, so 2A, 2B. 2A is 482 mm, 2B is 309 mm. Right, for this exercise. Of course, when you do project B, you will have to select your own lug as well as the pad size accordingly. But 2A, 2B is used right for our next question. Okay, now we are going to look at the stress. Alright, longitudinal stress S1. Alright, this is for question 6 part A2. Alright, partner X have to do this. So you are given, alright, let's say now you need to, why we want to find out all these values because of formula required us to find out those values. So let us work out this together, right? Try out first. This is radius, mean radius. You are given diameter 1500 mm, shell thickness 12 mm. So you find the mean radius, alright, from this diameter and shell thickness. So this is what happened. Your diameter here, and of course you have thickness, right? Thickness. So you have to find the mean of the thickness and diameter together. So it's a half of diameter is radius, right? Alright. Then this Q is your mass times gravity of your lug. Alright. So this is a moment, alright. The mass times your gravity. Alright. So over here the mass just now we find out, alright, 9,000 pounds. Alright, just now we selected the lug. Times gravity is your Q. Alright, after that, mean radius divided by T. Alright, so T is 12 mm thickness. 2A, 482 mm. So you know how to find A value. 2B, 309 mm. You know how to find B. H is actually from the table. Alright, this H is from the table. LF over here plus pad thickness plus 0.5 shell thickness. Alright, so pad thickness and shell thickness. You can see from here, pad thickness similar to the shell thickness plus half of it. So how do we know LF? Okay, given is 5.5 inch from the table just now, from the lug table that we saw. Alright, so you are given all these values. Please do some calculation here, find out the value. Then after that, with this, you are able to proceed to find out the S1. Alright, so this D or beta, this beta or D, you have to apply this formula, right? When you find out A, B, you have to substitute this into the formula there. question 5. Oh, no, actually this is a question 6. Question 6 of partner X. This is to calculate the luck, the stress distribution of our luck selected. Question 4?
Yes, please.
Alright.
Yes,
Okay.
thank you.
Right, so can you do until this, the beta or D? Anyone found the value?
0.27487.
Alright, so probably you want to tally your answer with this solution. Alright, so the mean radius, alright, diameter divide diameter, half diameter and half shell thickness. So you get 756 mm. Alright, so your Q, your mass of your lug times acceleration, gravity. Alright, so you get this Newton value, right? And RT, R over T, you get 63. Right? Why is that important, RT? Because later we have to use this table. Alright, this table allows us to find out the C or shape factor. Alright, so this RT is important for us to find out the shape factor. Okay, and then B over A also important because 2A 2B just now I show you 2A 2B. Alright, you're able to find out what is a B over A from here. They'll also help us to find out C1 C2. Alright, so over here you can see R over T is 63 mm. Alright, so A just divide 482 over 2 get 241. B 309 divided by 2 you have 154.5. H, alright, you have your 5.5 inch plus a back thickness similar to your shell thickness 0.56, altogether 157.7 mm. If you wonder why we need H, right, then in this case you go back to the formula here. Alright, you need H here. You need H here, right?
Sorry, why is back thickness 12 mm?
Oh, because our shell thickness is 12 mm.
No, the pad thickness.
The pad thickness, because similar to the shell thickness 12 mm.
Oh, okay.
But for your project just now I mentioned, right?
Oh,
Not more than 1.5
lah.
times.
Okay.
Alright, so just to make it simpler, we take it as shell thickness similar. Okay, so after that, our D or beta, alright, for this particular value, we need this beta. So 0.275, alright. So now what happened is, to fulfill this S1, we already found out the Q, we found out the H, we found out the beta or D, we found out the radius, we have a thickness. Alright, the only thing we don't have is C1, K1, K2, C2. Alright, so that means C1, C2, K1, K2 we don't have. Alright, but when to find this C1, C2, alright, then we have to come here. Appendix 5, Appendix 5, this table. Alright, so just now we have seen this beautiful graph to find K1, K2, K3, K4. Alright, after that, page number 113, you have this, this table, right? Okay, so just now, what is the value of BA? And what's the value of RT from our exercise just now? Over here. Huh? So we want to find out what is BA. What is RT? So BA is 154.5, right? 154.5 over
241.
241. Then RT will be 63 over 12, right? So can I find out the value here? Why is that important? Because the value allows us to determine, alright, these two parts. Right? Although you can see the table don't have the value we found out. You can see right, the RT is 50, 100, 200, 300. Then the B over A is 0.512. So how to make use of this table? Definitely you ask later, right? Now of course, what's the value for this? 154.5 and
0.64.
0.64. And 63 divided by
5.25.
5.2.
But why is it not 63? The
Sorry,
RM over
okay,
RM over T is 63.
RM just now is what? Just now the solution.
This one should be RM over T, right?
Oh, okay, already done. Sorry, apology. RT is already 756 over 12. Alright, so value 63. Okay, in order to find out this, right, C1, K1, C2, K2, okay, what we are going to do is interpolation. Alright. So first we have to find RT first. Alright, so you can see from here. As you know, our RT is 63. Alright. So according to our table, if I show you the table that we have. So we are looking at this. Alright. So now we want to fix the RT because our RT is 63. So it's between 50 and 100, correct? So we assume B over A is half. And then our C1 is for R over T 50, your C1 0.72. R over T 100, alright, so your C1 is 0.68. So now our RT is 63. So which one do you think? It's between this value, right? 72, between 72 to 68. Sorry, 0.72 to 0.78. 0.68, sorry, 0.68. In between these two values, right? So how to do interpolation? Alright, so this is how we do it. So you have 0.7096. Okay, 0.7096. So the next thing, to find out the final C1, next thing we want to fix RT. Just now we fixed B over A 0.5 to find out the C1, right? After we found C1, okay, we fix RT, R over T 63. This is our value, like 63. Yeah? Alright. And now over here, you can see B over A. Alright. If we go back to the B over A is actually 0.5 to 1, right? Okay, this is RT63. We found out from here. So now just now our C1 is 0.7096, right? Alright, so when our R over T is 63, C1 is 0.7096. Now our BA is 0.64, coming out from here, 0.64. Alright, so you want to find out the C1 over here. Okay, so again, final value of our C1 is 0.791. Anyone have any doubt about this? Because without finding out the C1, C2, you cannot do this longitudinal stress calculation. So I'm taking effort just to explain to you the interpolation. You must know how to find this C1, the final value of a C1. Because the table given to us, we don't have the value of what we want, alright? Because we calculated from our pad size, right? R over T is 63, but our table don't have 63, right? B over A is 0.5, B over A is 0.64. Ours is 0.64. Also not in the table. So how to find out the value? Alright, to suit our pad size, you have to follow this sequence. We have to do 2 times interpolation. Likewise for C2, but we focus on C1 first. Gentlemen, any questions? Of course, when you go back, when you project, at least you have some idea how to approach. Alright. Okay, now come to C2. Same thing. Alright, come to C2. You have to do the interpolation. Alright, so our C2 final value is 1.01944. Alright, so at least now you know how to find out C1, C2. Then we come to this graph. Alright, so just now we found out this D or beta is 0.275. 0.275, where to find? Just now from the exercise that we have. Alright. So over here, this is a formula we apply. We get 0.275. Alright, so when you refer to the graph, this is your D or beta, right? Then you draw a vertical line. This is 0.725 roughly, 0.275, sorry, 0.275. This is 0.25.
Not big enough. The biggest is 0.25.
Yeah, it's 0.23. My apologies. 0.275. This is a 0.23. Okay, so my apology. I think this is not to the exercise that I actually derived. But okay, so the idea is this. After you find your D, right, your K1, you find out your C1 already. Alright, then you use this graph, you find out the D. I think I used the wrong value here. So example, let's say now your D is 0.23. So you draw a vertical line, and your RT, right, this is your RT. Your RT is a 63, right? So it's in between 50 and 75. Alright, so you can see the line here. So you just, for the rough gauge, right? So 63 is above 50, between 75 and 50, roughly about this area. Just draw a line here. So this is estimation. You get your K1 roughly estimate about 2.5. Alright, 2.5. After that, for K2. Alright, so for K2, over here the x-axis is C2 D. Alright, so this C2 just now we found out from the interpolation. So you multiply, so for our example here, alright, so C2 beta is about 0.28. Also 0.28 is somewhere here, somewhere here. Right, 0.28. But I believe when you do your project B, value should be lower than this. So you can use the chart and then you plot. So by looking at this, the line here is for K2 is about 0.015. Alright. After that, you can plug everything in, right, into this S1, because you already found out your C1, C2, K1, K2, and all the necessary values are. Alright. Then you know this is S1. And finally, you must make sure that your S1 plus this is a PD over 40 similar to, right, PD 40 is similar to PR over 2T, right? They are the same. One is using diameter, one is using radius. Alright, so S1 plus this PD over 40 or PR over 2T. Alright, so you add them up together, must be lower than your wheel efficiency plus your tensile strength of your material. You have to prove, when you come to this, you have to prove your longitudinal stress, alright, is actually not greater, right, than this. Alright, so over here, this is how the partner X approach this question 6. Alright, part A2. For partner X, do you know how to do this already? X candidate. Alright, final thing is we want to find out S1, S2. So S2 will be the same. Alright, apply the formula, find out C3, C4, K3, K4 from this appendix 5. Alright, you can see, right, you have a C1, C2, C3, C4. And then you have K2, K3, K4, right? So your K3, K4 is for your S2. So you have to draw a line, and then you find out the K1, K3, K4. That's what I showed you just now. Okay, so now we're done with the lug selection. Alright, now we come to this project B, question 6 of part B. This is for the partner Y. We have to do these questions. Alright, okay, so this is called unity equation, referring to the column. Alright, referring to our column. So we have a 3 portion here. This is a compressive stress. This is a bending stress on the x-axis. Alright, so we have a air vessel here. Then we have a lug, alright, supported by this column, right? Column. So what happens if, let's say now, your column compressive, right? Because it's actually holding the wing or supporting the wing of the vessel, compressive stress. Then you have a bending stress. If let's say not eccentric, because it's not eccentric, it's eccentric. Alright, so you'll cause bending, right? So bending, you have bending on the x-axis and y-axis. Alright, so we want to find out these 3 portions. Alright, we want to find out these 3 portions. Compressive, this is called compressive stress. Alright, so this part, the first part is this compressive stress, followed by bending on the x-axis, bending on the y-axis. Okay, of course, right now you're not familiar, but over here, those are the notation. Alright, okay, so this one, like FOC, is a Euler critical stress. So it's typo error. So FAC is permitted axial compressive stress. Small capital F is actual axial compressive stress. Small letter FBC, unamplified bending stress. Capital FBC, maximum compressive bending stress. Alright, why we need all this if you ask? Because equation says so. We want to find all this value, plug into this equation. Alright, so just now this is a compressive stress. This is the bending stress, what we are going to see, right? So we want to find all this value to plug into this equation, such that you add up total three portions. Alright, must be not greater than 1. The whole idea, unity equation, is to find a quick way to add up these 3 portions: compressive stress, bending stress on the x-axis, bending stress on the y-axis, not greater than 1. Means our column, our design column, is safe to hold the weight of the air vessel. Okay. Okay, now we come to exercise. Alright, so over here, given, okay, now let us read this together. Over here, given column length is 1 meter from the lug support plate to ground. Effective length is 1.5 times this. Right? Determine the column size from appendix 8A. Right? So this is the table you need to refer to. To support the lug with B1 and LF, just now we saw 197 mm. Determine eccentricity of load. Alright, all these you can find from here. Let me check the solution. Alright, so again, because let's say the lug is 197, alright, so definitely you have to find something larger than 197. Alright, so again, we have to select the next higher one is 203. Yes, appendix, this one, appendix 8 from the canvas. Yeah.
The sample question.
Sample question. Not in the canvas. That's okay. If I say yeah, then I'll post in the announcement. Alright, so right now because 197 is a lug size example. Alright, so the next higher alright column that we have is 203. Alright, so eccentricity of loop. Okay, so over here you can find out 203, nominal size is 8 mm. Alright, so what we have here is okay, so eccentricity of load is actually half of 197. This one, because this is 197, right? So half of it, this part is 197 divided by 2. Alright, so this is, you need to take note of this. Right? How to determine eccentricity of load? You have to divide V1 over 2. Okay, so now let us take a look at this. Determine the following properties of this column 203 times 203 with nominal thickness 8 mm, column with square hollow section. Alright, you find out, right now you can download from Canvas. Alright, then you try to find out this value from the table. So do some exercise because you need to, even for your exam, you need to know how to find out this gross area, your this initial moment, z value, radius of gyration, Fy, U, and also bending compressive stress. Right, those values actually can derive from the table. So right now, just do exercise looking at these. What is the value for 203 times 203? Alright, so let us look at the solution here. Okay, so how to familiarize ourselves? Alright, so we look at this 203, 8 mm, right? Okay, so your I is actually here, huh? 37.5. Alright, and you must know the unit, right? 10 power of 6 mm power of 4. So you have to follow this unit. So your exact value is 369. Alright, the unit is 10 power of 3 mm power of 3. Radius of gyration R is 70.9. Your yield stress or yield strength is 350 this part. Yield stress or strength is 350 megapascal. So your FBC, where can you find this one? Alright, FBC, come here. You have this, alright, another table allow us to find out this value. Alright, 223. Right, now we look at the 203 dimension, 203 times 203, nominal thickness 8 mm. So you draw a line here, then you can see compressive bending stress. 223. This is important because if you cannot find this, you will stuck. You will stuck. You cannot find this, right? Then if you ask why you need to have this FBC, then I have to show you back the unity equation. This is our FBC. 223 megapascal, you have to substitute it. FBC X, FBC Y, same value. Okay, now determine ratio, slenderness ratio, and Euler critical stress. Alright, why we did this? Because our unity equation needs this. Alright, so determine just now from the table effective length, gyration from the table, and after that you plug this into this equation. This is Young modulus. Alright, Young modulus. We use our value 207. 207. megapascal. This is your so please take some time to familiarize yourself with this because eventually you have to use this during an exam. Alright, so you want to know the Young modulus, please go to our table B3. Our design temperature is 100 degrees Celsius, so you can find your Young modulus there. So let us look at the solution here. Slenderness ratio, alright, effective length is 1.5 times the length of our column. Alright, and then this our radius 78.9, we get 19. Alright, so later on our Euler value. Right, so this is your Euler critical stress. So I believe this is 10 power of 6, right? So megapascal, right? So 207,000 times 10 power of 6, you'll get this value 5659.3 megapascal. Alright, so you need this. Why we need this Euler critical stress, FOC. Right, so to plug into this. In case you wonder why you want to find out this, why Euler critical stress needed? Because of this. So that's how we found out the FBC, the bending, alright, stress, and then now we have Euler critical stress. Okay, now we come to this. Permitted axial compressive stress and actual axial compressive stress. Alright. So over here the formula given. Alright, this is your actual axial compressive stress is Q. So Q just now is mg, right? Remember? So Q just now we know is the mass of your lug. And then area just now you found out from the table. So I just give it a try. Then for the permitted axial compressive stress, we have two ways to find this. One is using this the chart, maximum permissible stress. Alright, because our slenderness ratio just now we found out is 19, somewhere here, somewhere here. Alright, and our yield is 350. 350 somewhere around here, somewhere around. Of course, this is guessing estimation. If you follow interpolation, will be more accurate. Later we will see how to interpolate from table 6.1.1. But this one also from appendix, you can find from here. Alright. According to your slenderness ratio, you're able to project or estimate depending on your this yield stress. Ours is 350. So now you determine this actual axial compressive stress. This is the first portion. According to our unity equation, this is the first portion talking about the compressive stress. Right, so let us have a look at the solution here. So this is a table 6.1.1. Alright. Over here you have your slenderness ratio given is 19, right? So over here you have to over here is your yield stress or yield strength, 350. Alright, so over here you don't have 350, right? So that's why you have to interpolate. So right now you have here is 350 in between 340 and 360. Alright, so for this maximum FAC, right? So your yield strength is 350. If you use interpolation, alright, in this case you have to find out between these two, alright. 340 between 203 and 215 is 350. So right now about half, right? 203 to 215 is about, what's the difference? 12, right? Alright, 12. So 203 plus 6, 209. But because this is 19, so you have to interpolate again. So you can roughly get about 207.1. Okay. And just now we mentioned about this FAC, actual, alright. So your Q is your mg, alright, and then this is effective area 6030 mm squared. So where can you find these? 6030, right? Effective area. So with this, we are able to find, alright, permitted axial compressive stress and actual axial compressive stress. Permitted also considered as maximum, maximum permitted axial compressive stress. So you can find from this chart, or to be more accurate, is from the interpolation. Of course, you can use either one of these, and then justify yourself, right? Okay, now come to the unamplified bending compressive stress. Okay, so this is your FBC, small letter F. We call it unamplified bending compressive stress. Second and third portion, right? Determine, right? So this is given, alright, given formula. So you have to apply this. So all this can get it from the table. Just now the eccentric, right? 197 divided by 2. Your Q also, just now, this one, your Q is mg. Q. So spend some time to figure out this. I hope now you look at the table, more familiarized with the table. when you do exercise, right, let me flip the attendance because just to confirm to this attendance. So now we have 5 absent. Alright, just the double check. Pradiswaran, Mr. Pradiswaran, no? Edmund, Amin, Nazir, and the last one is Ashraf. Anyone know them or not? Confirm they are absent. Alright, so in this case, I will confirm attendance for today. Alright, also I want to bring up important point just now in the beginning of the class. For those who came late, at least I have a chance to highlight to you again. Alright, so submission of project B is on the 30th July, Sunday. Alright, so please submit before 9 p.m. And also we talk about the pre-exam workshop announcement made on 10th. Alright, so Dr. Vivian will come on the 27th, 28th, 29th. So Thursday, Friday and Saturday. I believe 27, 28 will be 6:30 like what we have right now. 29 you have to confirm with Dr. Vivian, see what time she wants to start the class. And finally, final exam, alright, is open book. You have to come here on the 13th August, Sunday. Tentatively, the time fix is 2 p.m. to 5:15 p.m. Alright, so 3 hours paper, 15 minutes for you to read, alright, the exam paper.
So what do you mean by open book? Can you bring anything along?
Yes, open book, yes, you can accept computer.
Okay.
Only open book. So just now, gentleman was asking, your AS12110, right, you have to print out.
How you do print now? There are 100 plus pages.
Yeah. I believe so, because you cannot access your soft copy.
You cannot bring laptop but can bring phone.
Phone also cannot. All these electronic media you cannot use. Open book can. Alright. So last year I was told you cannot bring all this laptop or soft copy. Okay, so come to this exam, right? What I want to advise you, alright, especially come to project B. While you are doing project B, I want you to put in more effort. So at the same time, you can do well in the exam. Alright, so you need a column. Alright, just now the column calculation, how to use the table, right? Right, 203 times 203, nominal thickness, all these, right? You have a gyration, all those things that derive from the table, you need to know. Because partner X properly do the lug support, then you probably don't focus on the column. But for exam sake, you have to understand column as well. Alright. Followed by the boat force. Alright, remember this is a question 5. Alright, boat force, how you determine, alright, the boat used for this, the flange. And also the other one is the opening, the branches. All right, opening branches. The pipe that we use, right? Cut away the opening. How to, all right, compensate, right? The area. All right, area. How to calculate area A, A1, A2, A3, A4, A5. Right, want to compensate area, right? So this is DT, right? Remember? So this one you have to pay attention or put in more effort when you do project B. Put in effort, know how to do this question or similar questions. Also safety valve selection. This project E, project E. Probably some of you probably forgotten how to determine safety valve according to your set pressure. Right? Whether fire, mild fire. So this one is how to determine the safety valve use for that purpose. Another one is those are the flywheel used for your piston compressor. All right. Important is to know how to find out this I. All right. Second moment of mass. This is under project B. So right now it's end of June, right? Today is 30th, I guess. Yeah, last day of June. So you have another one, about 6 weeks to prepare for your exam. By using this project B, alright, effort that you put in, so that you no need to be worried about your exam. When you do project B, at the same time you are able to revise. Okay. Alright, so we come back to this. What is your solution? What is your answer? Anyone can answer? Alright, so our Q, okay, actually just eccentric is 93.5. Alright. So your Z value is 369 times 10 power of 3. Alright, so I cut and paste, so the power of 3 actually becomes typo error. Alright, so this is how we get your unamplified bending compressive stress. Okay. If you wonder why we need this, you can see FBC, right? FBC, small letter F. Alright, so this is a part that you have to plug in. FBC. This part, this part. Alright, so with this, I believe I give you some idea how to approach. Alright, these are question 6, log selection as well as a column selection. Alright, so now I have to explain about question 4. Alright, so question 4 only 1 mark. So do together. Decide on an appropriate type of well for longitudinal and circumferential seams, given that a well efficiency of 85% is to be achievable, and provide a dimension cross-section sketch. Alright, so we have to refer to clause 3.5.1 and tables and figures that are in clause 3.12.6. Alright, so we go to the 3.5.1. Alright, so over here you can see 3.5.1. Alright, refer to this welded joint, types of welded joint. Alright, so over here type A is a longitudinal. As you know, right, our purpose of our project, alright, after you select the shape metal, you are going to fold them, right, you are going to shape them like this as a cylinder. So you have to weld this part, right? Weld this part, after you fold, this part is called type A longitudinal welding. So this is type A longitudinal, right? Okay, so over here there are longitudinal welding, welded joint in main cylindrical shaft, transition in diameter or in nozzle, or joint in position require equivalent weld. These include circumferential or any other welded joint within spherical shaft. Those are always cylindrical. Alright, so we don't look at this. Type B is circumferential. Alright, circumferential means because we later on after that we join or weld together the semi-ellipsoidal head, right? Semi-ellipsoidal head. Those are the circumferential weld. Alright, so it's called type B. Alright, so this is what happened. Type A, longitudinal. Type B, circumferential. Alright, so example given here as well. Alright, circumferential. So you have to sketch example like this and then indicate. Alright, because what happens is ours, because you, depending on what type of sheet metal you use, right? If let's say you use 2 pieces, let's say your this air vessel is actually long, right? The length is actually very long. You have one sheet metal probably not enough, then you have the 2 pieces to cut, right? And then you have to show, alright. Of course, if a single piece easy, very nice, alright. Just one line, right? If let's say you have 2, means 2 sheet metal, you have to design such that the seam cannot be nearby together. Alright. So again, over here they will show you what type of weld we use. Alright, so you have to determine which type of weld that can achieve 85%. Right. So over here they will show you 85%. Right. So you have to do some reading and determine which one, alright? So which type of well you use, depending on the thickness of your selected sheet metal, alright? So recommended thickness. So in this case, 1.5 to 3 mm maximum, I don't think can be used for our project. Alright, so you have to find the one that is that meet your requirement, and then over here is a double. Alright, for type A, you have to read all this to determine which one you use for your project, for the welding part. So over here, I believe very safe lah. If let's say you recommend this or you suggest double welded single V butt joint, alright, you can see the thickness applicable to all. Alright, so circumferential and longitudinal joint. So you can see, right, applicable to what we discussed just now lah. Type B and type A, right, type of joint. Right, so if you look at this, of course, seems applicable to our project. So you have to attach, alright, this diagram. Let's say you decided, alright, which one to use, then you have to attach this on your report. Alright. Okay, now for question 4. Alright. Okay, any more questions from class regarding project B? You better ask now. If not, difficult. Let's say you use email will be difficult. So which part do you think you still need clarification? Just now I mentioned about this, the mass of your, this to find out the mass of your, the mass, right, total mass, to find out the weight of the air vessel. Alright, so is your water or oil plus your cylinder plus this one, the straight flange from your semi-ellipsoidal head. Alright, so this SF is your plus your semi-ellipsoidal. Total weight, you have to include this. The length of your cylinder, you have to include this. I should say exclude. That means this is your cylinder, alright, and then this is your semi-ellipsoidal head from the vendor, right? So this part, apply formula 1.09 something just now, alright. Cylinder, your sheet metal, and then this part you have to include. This part is this part from your catalog. Okay, so just ask question 3, right? Because last week I emphasized on quadratic equation, you will get your diameter. Anyone still haven't get your diameter? The diameter of the air vessel. Anyone still struggling about it? Do you plot the graph? Quadratic graph? So roughly what is your diameter? I just want to confirm whether you get the right, the approach is right. 1.286, okay. Between 1.2 to 1.3 is alright. Anyone didn't get this 1.2, between 1.2 to 1.3. This is a last time to clarify. Anyone don't get between 1.2 to 1.3?
So if my diameter is 1.28, can I choose 1.29 from
The catalog.
Yes, from the
Yes. You,
It's too close.
huh?
Is this too close to choose 1.29?
Too close? No. As long as very close to your value, will be fine. Yeah.
Just like I calculate the total. From project A, my total is 6.313.
Oh, and
After this one, I get 6.317.
6.317. Oh, you mean the volume?
Yes.
Oh, doesn't matter lah. Alright, so which point you need clarification for project B? Anyone still struggling with question 3 or not? The quadratic equation. Alright, so once you get your question 3, your length of your air vessel, alright, because it will determine question 5, right? Your length determine question 5 because the total mass, alright, of your air vessel you have to get from question 3. Okay. Then question 4, just now we already discussed, just determine what type of welding you use. Alright, because to achieve 85% weld efficiency, right, find the proper welding methods. Then question 5, as I shared with you, inspection opening, alright, determine the flange cover, and then also the opening, alright, about the area, A1, A2, A3, A4, A5, in case you use reinforcing ring. Alright, followed by the bolt that you use. Alright, also important, you need to know the bolt force. And then also important is determine whether hydrostatic means operating or sitting, right? If let's say there's a pressure from the vessel, it's called operating. Without the pressure, it's called sitting. All this you need to know and then able to do the questions. After that, today we discussed question 6. So we did exercises. I believe will give you some idea how to approach this because for this question 11 marks. If you can do this one, at least the rest, at least you are able to pass. Alright. So if no question, I will not hold you back. So we'll call it a day.